Hello everyone. Dunia hi laws of motion topic chapter sunga friction topic ibol de hin video ma sa chu normal to tension ibol chai ta na. So contact force chu is ma normal ma tension ma friction jara na thum ta amza. So out of those three we have done normal and tension. Okay, so now we will do friction. Friction force hu hila pa da hung kondo ha. So what how does friction force originate? See, bodies nina. Suppose any two bodies, okay, if they are in contact, right? So any two bodies when they are in contact. So at the point of contact, okay, at the point of contact, so here you will have a contact force. Microscopic level, so there are molecules, particles, okay. So due to the attraction of this interaction of these particles, so it creates a contact force. So you'll have a force. Let's say this is contact force Fc. Okay, Fc. So contact force will act on both the object. So it will act on both bodies. Contact force so this is an opposite force. Okay, it acts on both the bodies. It is equal and opposite. Okay, right? So this contact force, like contact force so we can resolve this into two components. Split component niya. So one component perpendicular, another component parallel. So one component perpendicular, another component parallel, F parallel. Chilaya perpendicular component pahe na, pahe normal force kitia, parallel component pahe friction force kiticho. So if you recall, normally ball pelva condition khatcho pita normal force adding acho. Perpendicular hinga chula na contact surface to. So this is where it started. Okay. Ajichu friction normal force pahe contact force perpendicular component. So it is the perpendicular component of a contact force. That is why it has to be perpendicular with the contact surface. Okay. And now we are going to do friction force. So friction force is that component which is along the surface. Okay, that means friction force will always act along the contact surface. So this is the normal force. Okay, and this is the friction force. So let's see what is friction force. Friction force is a resistive force. Resistive force opposing force. So it will try to oppose, okay, the motion. If you oppose the relative motion between the two bodies in contact. Bodies so it will oppose the motion. Relative motion kinematics portion relative motion in 1D 2D volt. So you have some idea of relative motion. Okay, so that relative motion it will try to oppose. Okay, I will show you this in after some slides when I teach you the direction of friction. Okay, and so friction can exist between two solids. Okay, two solid contact so you'll have friction force, and it can occur between solid and a fluid, and you can also have between two fluids. Okay, if it exists between two fluids, then we call that as a viscous force. Viscous force class 11 second part so you'll have properties of fluids. Okay, so there you'll have viscous force. Okay, so laws of motion so we will be dealing with only solid surfaces. Okay, so if two solid objects are in contact, so what friction force you will have depends on so we will be seeing that one. The friction force you have two types. Okay, if the two solid bodies which are in contact, they are sliding. Okay, so example, two A and B are in contact. So if either B is sliding or A is sliding or both of them are sliding, if there is a sliding or I can say slipping, so that friction force is the kinetic friction. Bodies if they are not sliding over each other, then the friction in the surface contact surface is a static friction. Okay, so let's go a little bit deeper into this kinetics and static. Kinetic so bodies in contact so if they move with respect to each other. Okay, so that means you can also say rubbing, you can also say sliding, you can also say slipping. Okay, so that friction force is the kinetic friction. And direction of direction part has kinetic azong, static azong. So direction so here we see velocity of A with respect to B relative so we have done relative. Okay, magnitude magnitude so the magnitude of kinetic friction so this will be given by this formula. F equals to mu k into n. Mu k here. So what is this mu k? So mu k is the coefficient of kinetic friction. Okay, and n here n to normal. Okay, so this is the formula to find the magnitude of kinetic friction. Okay, next you have static chip here. So when the two bodies in contact, so they are not sliding. Okay, so both of them are at rest. Na static chip here. So static is basically rest. Okay, static means rest. Yeah. So you have static friction. Magnitude of static friction too, same formula. Okay, mu into n. So in case of static friction, you have mu s. Okay, mu s chip here. Coefficient of static friction. Okay, n to n to normal. Okay, so F equals to mu s into n, which is magnitude of static friction. Okay, so here remember one point. So the magnitude of static friction is self-adjustable. Static friction magnitude it can be low, it can be high. It depends on the external force. As I will explain it. Okay, but remember this point, it is self-adjustable. Next, direction of static friction, which is direction pasang here, as I explained. But remember this point, so it acts in such a way that the net force on the body is always zero. Net force zero, net force zero means the body is at rest, right? In order to be static body to rest. So here, so the static friction acts in such a way that the net force of the body will be zero. Next thing, limiting friction. Limiting friction. So what is limiting friction? It is the maximum static friction, the maximum value of static friction. Static friction is self-adjustable. It can change. Okay, it can vary. It can go high, it can go low. The maximum value it can go, so that is the limiting friction. Okay, so limiting friction is mu s into n. And in general, so mu s, static friction coefficient, is slightly greater than kinetic friction as you but microscopic level. So when you see, so when two solid bodies are in contact, okay, you have contact force. Contact force ho ako particles ho na. Particles ho interaction, attraction ho ako na so atile body tin sa ki slight phala chun it's a particle ho ka interaction pa hai na. So this becomes weaker. Okay, so when it becomes weaker, so the friction force, the contact force starts becomes lower. So here you have mu k is lesser than mu s, so mu s is greater than mu k. Okay, so static friction is always less than limiting friction. As you limiting friction too, it is the maximum value of static friction. Okay, friction for static and kinetic friction does not depend on the area of contact. Okay, but it depends on the material. As you plastic rub if in compared to that, metal rub okay, it will be difficult to rub it. Okay, so the plastic may be smoother, right? So it depends on the material. Suppose I have a block A, okay, and another block B, body, okay, body A, body B. So let's say A moves with 2 meters per second and B moves with let's say 4 meters per second. Okay, so if I want to draw the free body diagram of B, if I want to draw the free body diagram of B, so I have to sit on A and look at B. Relative topic involves velocity of B with respect to A. So this is VB, okay, minus VA. A katawa B as B diagram draw. Okay, so how much is this? 4 minus 2, so this is 2 meters per second. B pa draw dinga. So this B is moving 2 meters per second with respect to A. Okay, relative motion relative motion so it is moving towards the right. Okay, so that means friction opposes the relative motion. Friction should act opposite to the relative motion. Okay, this is friction to okay, so similarly, if I sit at A and look at B, okay, I want to draw the free body diagram of A. So then velocity of A with respect to B. So velocity of A minus velocity of B. Okay, A to Z ham 2, B to 4. So this is minus 2 meter per second. Okay, chichu pite na ham B na tawa A to na vela chun A to vai langa chi 2 meter per second na. So that means if this is A, so here A is moving 2 meter per second towards the left side relative to Z lang vai langa na. Okay, A is moving towards the left, so the friction force will act towards the right. Friction force to Z lang tayo ngai. Okay, so this is how you draw the free body diagram direction of friction force. Okay. Alhang pi a question apply para na. So in physics mechanics part, most of the questions are asked based on ground frame. Okay, ground frame to ground chunga hi. If I put the block here, okay, so the block is saying, let's say, moving with 2 meter per second. It means that the speed of the block with respect to the ground is 2 meter per second. Na. So the whole motion is along the right side. Okay, so that means to oppose this, friction has to act on the left side. Okay, so that means in this case, friction will be on the left side. So whatever is given, okay, with respect to the ground frame, you can simply use that. Okay, block with respect to the ground, so that means the relative motion is along this side. Okay, so the friction has to be on the opposite side. Okay, let's do some examples. Suppose I have a 5 kg block. Okay, so 5 kg block is on the ground. On the 5 kg block, let's say force of 20 Newton is applied. Coefficient of friction to mu s to 0.5 kp na. Question to piham tele 0.5 friction or malachun. So this surface is basically rough. A rough surface. Friction to rough surface question also surface is smooth. So if it is given surface is smooth, so that means there is no friction. Okay, so friction is 0. Right? So smooth means friction, no friction na. Mu kp. So if you find there is mu, so this means that the surface is rough. Okay, so if the surface is rough, then you'll have friction. Tu chana question solve aso last video chana long so mu khat vai sai man khalok piu chana na, because we assume the surface is smooth. Okay, frictionless surface. Kutila chila question ahi, will the block move? Okay, kutile, let's see. Here I have 5 kg. So weight of 5 kg to 50 Newton. Achung lang ahi normal dingin din. So zil lang ahi 20 Newton na. Kutile tang block to rest na ding acho. Ajo static friction direction to biha. So direction of static friction is such that the net force of the body has to be 0. Okay. Net force 0 hilachun body to rest na. Rest means static. Okay, so static friction is defined only if the body is at rest. Kutilachun external force silanga malachun chi cancel nothing acho, it should be in the opposite direction. Okay, so the friction force, right? Okay, static friction is along this side. This is direction na. Kutile chilahi batang external to 20 na. Static to head mabang, so it is self-adjustable. Okay, the value can change. So here, see, whatever maximum value of static friction is possible. So if this value, as long as this value is greater than external force, so the friction is strong enough to keep the body at rest. Okay, so once the external force is greater than the maximum static friction force, then the body starts moving. Okay, example, maximum static friction, so let's say here it is 15 Newton na. Kutile external to 20 hisa 20 to 15 sangalin na. So that means the whole thing is going to go towards the right. So let's find out what is the maximum friction here. Okay, so maximum static friction, that is the limiting friction. So mu s 0.5 into normal so that deha vertical lang ay chang opicula na block so kichom le opicula. If it is going to move, it is going to move only in the horizontal direction. Okay, so there is no movement along the vertical. So that means the normal and the weight cancel each other. Okay, so they are equal and opposite. So normal is also 50. So this is how much? 25 Newton. Okay, so here you can see that the maximum value, so maximum value hai na, see limiting friction pa hi external force sanga lin jo na. So that means the friction is strong enough to cancel out this. Okay, the body will not move. limiting friction to 25 chule na limiting to 25 ahile to ahi static friction chu zat de ha. What will be the static friction? 5 kg chu changa 20 chule na static friction chu bi ha, it will keep the body at rest. Okay, so the body has to be at rest, net force to be 0. So therefore, static friction should also be 20 Newton. Okay, only when it is 20 Newton it gets cancelled out, net force becomes 0. Nah, so if this 20 is given as 10 Newton, so the static friction should also be 10 Newton. Okay, self-adjustable kiti pa na chikiti na ito. So it depends on the external force. External so 10 hela chun static jang so 10 hingai na. External so 20 hela chun static jang so 20 hingai. Aji to net force to 0 ako hingai. So body to rest am te hingai. Okay. So here these are the static so here in this particular question 20 is given na. 20 kp is achu so external force 20 is achu friction force jang 20 hingai. Okay. So friction force is 20, maximum friction force, limiting friction is 25. So the body will not move. Okay, because the friction is strong enough to overcome this external force. Okay, so in this same question, what will happen if I put the external force to be 30 Newton? Okay, everything is the same. Everything is same. 5 kg, so mu is 0.5. Kutilachun maximum friction to be the maximum friction to 25 Newton chalana. To a heavy external force pa he maximum friction pasang ahi sangzo tacho. Okay, so now the friction is not strong enough to hold the body at rest, so the whole thing is going to move towards the right. Okay, with some acceleration. Using that same example, suppose I have 5 kg. Okay, so force is 30 Newton. So what happens now when I apply 10 Newton, additional 10 Newton downward? Okay, so mu chu kibang na, mu chu 0.5 Newton. Okay, so in this case, same question, will the block move? Okay, so here the block chalahi 50 Newton to weight chalana. Achung langahi normal omdingin. So zilanga chu 30 Newton ki apply. Okay, and then you have the friction force on the left side. Okay, everything is same. Okay, you have additional of 10. Okay, normal is that. So along the y, net force is 0. Okay, no movement along the y. So here I will have n plus minus 50 plus minus 10 should be equals to 0. Okay, so n will become how much? 60. So normal force is now 60. Okay, limiting friction to that. So what is the maximum friction? So that is 0.5 into 60. So this is 30 Newton. Okay. Maximum friction in 30 is external force so 30 chalana. So now see the friction force is able to cancel out the external force. Okay. So now in this case the body will remain at rest. Okay, so let's start solving questions. The first question, you're given that contact force, normal force to friction force to keep it. So F, Fn and then small f. So see, we know that contact force to pita mas contact force pa hi na split vale na. So if you split a perpendicular component and a parallel component, you have the friction force and the normal force. Okay, friction force to normal force pa hi na plus vale contact force pa yung poto di nacho, right? So I can take an example here. Suppose I have a vector 3, I have another vector 4. So when I add these two vector using vector addition, is that 3 square plus 4 square. If I take the angle as 90, okay, so 2 into a into b into cos 90 is 0 na. Kutila chi zarang podo dia 5 ung poto dita so. Chichu pitinam tele. So here if contact force is 5, then the normal and the friction are 4 and 3. Okay. Kutile velojun chi resultant pajola na. So the individual vector will be lesser than the resultant. Okay, that means so the contact force will be greater than normal force and it will also be greater than the friction force. Okay, kutile option A jong di, option B jong di na. Option C ne hi pi ha. So normal force to friction force so hui pen lin jo de ha. So we cannot say, okay, hi chipa jong lin thai, chipa jong lin thai na. So it can happen because even if I take 4 here, if I take 3 here, the resultant is again 5, right? So one of them can be lesser than the other. Okay, it depends on this angle. So here third option is not correct. Okay, to check for answer, you put these values. So if n minus f to 4 minus 3 to 1 na. Capital F to 5. 4 plus 3 to 7. So this is true. Okay, you put value putting bolation. Okay, next question. Mark the correct statement about the friction between two bodies. Must happen. So static friction is always greater than kinetic. So this is the end depends on the low pitch na. As you static friction value it is self-adjustable. Okay, it can change. It may be less than kinetic friction. Okay, so first option is wrong. Second option, the coefficient of static friction is always greater than coefficient of kinetic friction. I have explained this already. Okay, it is correct. C to limiting friction is always greater than kinetic friction. Kinetic friction in compared to the limiting friction, it is lesser because on sliding, so the contact forces decreases. Okay, at a microscopic level na. Abana D to limiting friction is never less than static. As usual, limiting friction it is the maximum value of static friction. Okay, so therefore static friction will always be less than the limiting friction. Could the answer to B, C, and D. Okay, question number 3. Statement nikipina the limiting force of static friction depends on the area of contact. It does not depend on the area of contact. So one is wrong. As our point is peninsula na. So it does not depend. Okay, static friction or kinetic friction does not depend on the area. It depends only on what? The material, right? So statement 2, it is independent of area. That is correct. It depends on the material. So that is also correct. Okay, so 1 is wrong, 2 is right. Okay, you have one question here, J question. So mass of 10 kg is lying on the horizontal surface. Okay, force to 30 degree coefficient of static friction kipina. So that is 0.25. So on this surface you have mu equals to 0.25. Question to PM. So the block will just start to move for the value of F. Okay, you have to find F value na. So for what F value, the block will just start to move. Start to move. Suppose I have a block here, so I have force here and then friction force here. So if F becomes greater than equals to F, small f, so only then the block will start to move. So as long as small f is equals to capital F, nah, so the whole system is at rest. Okay, just start to move kiti chula na. So here you can take F is greater than or equals to small f. Okay, it just start to move, right? So hiji condition pahi and manu equation ahe. So that means hiji F hol nothing ahe, small f friction pahi hol ngai chula na. So let's find out the friction force. Okay, you can split this force into what? F cos 30 and F sin 30. Okay. Kutile block part 2. So along this I have F sin 30 to F by 2 so na. Cos 32 root 3 by 2, root 3 into F by 2. Weight to that ham weight to 100 Newton. Abana normal so chung nangam ding. Okay. So you have friction force also, right? Khotele to ahi normal pai hol masarung ngai na friction hen ding aso normal ngai cha. So along the vertical, along the y-axis, net force is 0. Okay, movement is along the horizontal. So therefore, Fy equals to 0 ga bol chun ipyung po to dia. So n plus F by 2. So this minus 100. So this would be equals to 0. Kutile n chu zarang podam 100 minus F by 2. Okay, kutile normal chu kimota na friction force chu pita. So friction force chu mu into n chula na formula chu. So mu chu is 0.25 chu pia 1 by 4 chula na. 0.25 is basically 1 by 4. Okay, so 1 by 4 into 100 minus F by 2. Okay, so this is your friction force. Kutele given condition chu pia horizontal component force pa chuna friction force pa sanga alin zongai chula. So once this force becomes greater than this, so the body is going to start moving. Okay, so we'll apply that here. So once root 3f by 2 becomes greater than or equals to 1 by 4 into 100 minus f by 2, so then the body will start to move. Okay, till I f hold on. So here 2 1 is 2, 2 2 are 4, so 2 comes on the left side. You have 2 root 3 into f. Okay, so it will be greater than 100 minus f by 2. So how much is this? Multiply both sides by 2. I have 4 root 3 into f. Okay, should be greater than 200 minus f. F pa ko vela nga akong alachun. So 4 root 3 plus 1 into f should be greater than equals to 200. Kuti let's try the value is that they have 4 root 3 plus 1 here. 4 into root 3 to approximately 1.7 plus 1 na je. 7 4 28 6.8 plus 1 je chu pe ha 7.8. Okay, kuti le. So that means force will be greater than equals to 200 divided by 7.8. Okay, so this will be approximately 25 point something. Okay, 25 point around 6 will come. Chilai na. Root 3 value to 1.7 exact approximation in na. So it may be different from that. Okay, but approximately the answer should be 25 point something. So the answer is option A. Okay, 25.2 such imulo na root 3 value pa na approximation achieve ya. Okay, medical exam question na. Question to have maximum acceleration of a moving car so that the body lying on the floor of the car remains stationary. But then car a floor achu body kar na. So let's say this is one box. Okay, it is lying here. So mass is let's say m. Kutile car chu acceleration ia chi ala chun block pa chu nga hena. Block pa jong hi. So what will happen to the block? See, gari ay to pala khun gari khuna aung ki start pala khun aung chi pala khun ipitizia. So your body is thrown backward, right? So we call that what that is called pseudo force. Okay, imaginary force, right? Similarly, chilai block chunga jong hena. So when the car move forward, so a pseudo force is going to act on this block. Okay, so that pseudo force will act along the left side. So pseudo force, the block will be pushed towards the back sides. Which is pseudo force if you have mass into acceleration. Okay, with the same acceleration. Okay, if this body tries to go to the left side, so the motion, the friction pass so it has to be on the left side na. In order to put the body, the block at rest, friction pass okay, because the pseudo force is towards the left, right? Okay, friction force has to be along this side, and for the body to be at rest, so these two has to be equal. Okay, so the pseudo force has to be equals to the friction force. The formula applies in notes. So you have mass into acceleration should be equals to mu into n. Block pahi chilang hi mg na chilang mg achung lang ako normal chula. Kutile vertical motion na. So net force along the vertical is 0. So therefore n is equals to mg. Right? So from here I have ma equals to mu into mg. So mm gets cancelled out. Acceleration is mu into z. Mu is at kpm 0.15. Z is at 10 na. So you solve this one, you have 1.5 meter per second square. Okay, answer to B. Abana, a heavy box mass 50 is moving on the horizontal surface, moving kiti na. So that means you will have what? You will have kinetic friction. So you are given the coefficient of kinetic friction is 0.3. Okay, so you have a block 50 kg, mu k chu is kpm, mu k chu 0.3. Okay, kutile weight chu 500 newton, normal chu achung langa na. Horizontal vertical langa hin net force 0. Okay, movement umlo. Kutile n chu is n is equals to 500. Kutile question should be the force of kinetic friction. So force of kinetic friction equals to mu k into n. Okay, so here mu is 0.3 into normal to 500. So 3 5 are 15, 150 newton. So this is the answer. Okay, option I1 for the 7 kp here. So you have to take z as 9.8. Okay, so if you take z as 9.8, I have 550 kg into 9.8. Is that the so 5 here are 40. 5 9 are 45, 490 newton. Okay, so this is the weight. So the normal will be 490 newton. Okay, kutile friction force is at fk will be equals to 0.3 into 490. So 3 9 are 27, 3 4 are 12, 13 14, so 147 Newton. So answer is option B. Next, okay, another J equation. A block and a trolley system as shown in figure. Coefficient of kinetic friction 2 is at kpm, so it is given 0.4. Kutile chilahi mu k equals to 0.04. Chilahi veleochun tension hi kibangjana. See, you have a same tension. Okay, so here if I have T, so here I need to have T tension. Kutile mu to 0.04. Trolley hi veleochun, trolley hi 20 kg, weight to 200. Okay, normal chu achung langa na bana zil langa chu tension T uma. Okay, so vai langa chu you will have friction. Okay, as it chu net movement choi langa zil lang chola na, so friction will try to oppose that motion. Okay, so first let's find out how much is the friction force. Friction force is equals to mu k equals to how much? 0.04 into normal is at the vertical langa hi net force 0 chola na, so you have normal equals to 200. Normal to mg chu ke bang tin cho, so 200 for 2 are 8 Newton. So friction force is 8 Newton. Okay, kutile 6 kg pa ho, so 6 kg a weight to 60 Newton. Okay, upside I have tension T. Sign convention hai na. So here on the 20 kg he will on horizontal plane arm chala na. Horizontal plane arm ala chun sign convention to iti manu ta. So x is like this, y is like this. Okay, chila he will chun. So now you're going along this side. Puri na pha wahi pita, puri na pha wahi, you take a 90-degree turn. Okay, so you take a 90-degree turn. So here tang system ni cho string la ki zo banala na, sign convention ki bang na la ngai jo. So here I have xy like this. Okay, so after going through the pulley, so the string takes a 90-degree turn. Chita banga cho your coordinate system should also take 90-degree turn. You will have y here, you have x here. Okay, you turn by 90 degree na. Khutile chun chila have the 66 kg block ading a downward hi positive ta, so x axis chilang hi plus y na, upward hi minus x. Okay, so you have to follow that sign convention. Khutile let's say they go down by acceleration a. String khala ki zomban chala na, string khala ki zomban na la chun acceleration chu ki bang ne tin cha. So write the force equation in 20 kg T minus force friction choose 8, so this would be equals to 20 into A. Okay, equation 1 about 6 kg ako in 6 kg downward to plus na chala hi. Okay, so that means 60 minus T should be equals to 60 into A, 6 into A, so MA. Equation number 2. Go tell equation number 1 to 2 he plus volume. So add equation number 1 and equation number 2, you'll have, so T to minus T to get cancel out na. So you have minus 8 plus 60 should be equals to 20A plus 6A. So 60 minus 8 to 52 equals to 26A. So 26 into 2 to 52. So therefore A equals to how much? 2 meter per second square. Okay, so your answer is D. Abana, so next question from HCV. So you're given a system. 1 kg niyom na chong 1 kg ten yong string a kemana. Chit abalan chi whole system jong string a 0.5 kemat na. Kutela string is an mana string hi niyom china chi pen khat ja chi khat cho. So therefore how many tension you'll have? So let's say this is T1. Okay, T1. So this will be T2. Okay, T2. Abale village and abon wahi kimat chuna, so they are all connected. Okay, so they are connected. So that means if this goes down by A, okay, if 0.5 goes by A, so this 2 also goes by A. Okay, so let's write the free body diagram for all of them. Okay, so first you have 1 kg but mu to 0.02 chala na, khole friction force is at 0.2 into batang normal is at. So here I have weight is 10. Okay, so about I have n vailanga hi T1 Okay, so here I need to have the friction force. Vertical lang net force 0 chala na, net force 0 hile. So what will be the value of the normal? So the normal should also be 10. Okay. Kutile friction force zat jam. So mu to 0.2 into 10. So this means 2 Newton. Okay. So friction force 2 Newton. Similarly, 1 kg khapahu zilanga T2 uma vailanga T1 na. Abala vailanga friction zang na lai chala. So you have T1 plus you have friction, so which is again 2 Newton. Kibang chat chala na 0.2 hisa. So N will become 10. Soft lesson friction force ang 2 mamang pocket beta. Okay, so this will go towards the right with, let's say, acceleration A. First pass on acceleration A at seeding. Abana 0.5 pahu. So 0.5 kg. 0.5 away is at 5 Newton. Okay. Atong nga ho tension T2. Acceleration A at isude. Okay. So let's write the force equation. Kasi ba nga cho sign convention na 1 kg tiyan ya sign convention hi, it is like this. Okay, regular coordinate system xy xy. Okay. So now in the pulley you take a right turn 90 degrees. So therefore the coordinate also will take a right turn. So now this is y and this is x. The coordinate xy pa hi 90 degree turn bol chun. So that means 0.5 ading ahi downwards is plus na. Jipen hi plus y upward to minus x. Force equation zita 1 kg masapa hi. So T1 minus 2 should be equals to 1 into A. So that means A. Okay. 1 kg pa ko na. 1 kg lai pa hi. Force equation biha T2 minus T1 should be equals to 1 into A is A. T equation number 2. Abana 0.5 pa hi kasi bang ano lang plus atong lang negative. Oh. So that means 5 minus T2 should be equals to 0.5 into A. Equation number 3. Kutile to hin equation number 1, 2, 3 abon in gaagom liao chun. So 1 plus 2 plus 3. Ibing pod de ha. So plus T1 minus T1 gets cancelled out. Plus T2 minus T2 gets cancelled out. Remaining to minus 2. Okay, so here in equation number 2, you also have a friction force. Na friction force ang ngay sila. So minus 2 should be equals to A. Okay. So that means if I add them, I will have minus 2 plus 5. So this should be equals to A plus 0.5 into A. Is that the minus 4 plus 5 to 1. 2.5 A. Okay, or A will be 1 divided by 2.5. So 10 divided by 25. So this will be 0.4 meter per second square. Acceleration na. Question masa jung pito acceleration ado so na acceleration is 0.4 meter per second square. Abana hina si acceleration pa hi equation number 1 aput la chun T1 hung pod ta so. Okay. So how much T1 will you have? So T1 minus 2 should be equals to 0.4. Okay. So therefore T1 will be 2.4 Newton. Okay. So that is tension number 1. Tension number 2 pa itin holo diwham. You put the value of A here, okay, directly in equation number 3. Right? So if you put this here, 5 minus T2 should be equals to 0.5 into 0.4. Is that what they have? So 5 minus 5 4 are 20. 0.2 should be equals to T2, right? So therefore T2 will be how much? 5 minus 0.2 to 4.8 Newton. Okay. So acceleration to 0.4, tension T1 to 2.4, abana tension T2 to 4.8. Okay. So last question. PP given ham coefficient of friction between the table and the block. It's 5 kg pa hai na. Sila hi mu to 0.2. Okay, this is given. Kutil question on tensions and also tensions. See, you have two different string. See, string cut heza, sila nga string cut na. So let's name them. So let's say this is T1. Okay, T1. So this is T2. Kutile abona ay hoy lang nga ketol de ha. 15 pa lang ketol de na 15 to gi zo na. So 5 kg will go up with acceleration A. 5 kg will go acceleration A towards the left side, and then 15 kg will go down acceleration A. Kutela sign convention to pitam. So if it is horizontal, we have x and y. Okay, so now 5 kg para 15 ka chiala chun left langa 90 degree ka turn chala na coordinate pa jang hi left langa 90 degree turn le chun chilanga hi x ding chilanga hi y de. Okay, abana so 5 kg lang khalang pa hi x coordinate clockwise 90 degree turn le chun, so you're going clockwise 90 degree. Okay, so that means your xy will be y, and then this is x. 5 kg ke khai pa ding akho anui lang hi plus x achung lang hu minus x. Okay, abana chu 15 kg ke khai pa ding hi achung lang hi plus x anui lang hu minus x. Okay, negative direction to positive direction chana kutele. So first you have 15 kg to 150 newton achung langa chu tension T1, so this goes down by acceleration A. Abana cha 5 kg alaya pa khu veilanga hi T1 uma anung langa khu T2 na ama hi veilanga acceleration A to chidi. Abala chun additionally you have friction force also. Is that they have friction force here? So F equals to mu into N. So 0.2 into normal so that they have a weight to 50 chura na. Vertical lang net force 0 here chun a normal jang chu 50 hingai. Oh, so 5 to are 10 newton. Khotele 5 kg khapa kho achung langa hi tension T2 ma anui langa a weight 50 newton ding abana chi hi acceleration A chi taw na. Kutele force equation 11. So masapa hi tang masapa hi ka sai chu, so chung lang hi plus x anui lang chu minus x. Kutele so T1 minus 150, so this should be equals to anui lang chu minus x na 150 15 into minus A, so that means minus 15A. Okay, acceleration is negative chala. Okay, acceleration is downward, so it is minus. Bana chu alai pa hi zilang plus vailang minus na, so that means T2 is plus. Okay, minus T1 should be equals to, okay, you also have the friction who, so plus 10. Okay, so equals to minus 5A. Aji chu 5 kg hi zilang pa hi plus x is a vailang hi minus x na. Okay, so finally the third thumna pa hi downward is positive, so 50 minus T2 should be equals to 5 minus 5A. Okay, as you acceleration upward chala na 5 kg pa ko, so you have minus x, downwards to plus x, upward to minus x 5 kg ding ahi. Okay, so now you have equation number 1 to, let's say equation number 1, equation number 2, equation number 3. So you add all of this one, equation 1 plus equation 2 plus equation 3. Zarang po di ha. Plus T1 minus T1 0. Okay, cut cancel out. T2 minus T2 cancel out. Put the remaining to ha. So minus 150. Okay, so plus 10 plus 50 should be equals to minus 15A minus 5A minus 5A. Kutila chiza di ha. So 100 minus 90 should be equals to 25A minus 25A. Okay, minus minus cancel out. So what is A? A should be 90 divided by 25. Okay, 5 are 25, 5 1 is 5, 5 8 are 40. So 5 3 are 15, 5 6 are 30 meter per second square. Acceleration is 3.6 hong pot na. Kutele acceleration omala chun T1 to T2 chun hol na. You put this value here, you'll get the value of T1. Okay, you put this value here, you'll get the value of T2. Okay, kutele equation 1 akon put le chun T1 minus 150 should be equals to minus 15 into 3.8 chupi ha, 15 by 18 by 5. Okay, so T1 minus T1 should be equals to 150 minus, is that the ha, 5 3 are 15, 3 are 24, 3 1 is 3, 4 5. So this is 96 Newton. Okay, T1 is 96. Chita pa nga chu e pa hi equation number 3 put leo chun izan hong poda di ha. So 50 minus T2 should be equals to minus 5 into 18 by 5. Right? So 50 plus 5 cancel out, 18 should be equals to T2. T2 huzi langa chiding 18 pa hovei langa hong din na. So therefore what is T2? So this is 68 Newton. Okay, so that is your answer. Okay, so this much na friction video adi nga theory ho zo si hin. So like example khalini question khalini solve theu chu chan chu tin. So I hope you gain something from this video. Okay, video kit phalakun. So we will do miscellaneous question. Okay, so that involves normal, tension and friction all together na. Aballe inclined plane jong akit phalakun involved. Oh, so inclined plane is very important. Okay, we'll stop here. Right, so thank you for watching.